video we will go to discuss about the properties fluid, that is viscosity. Viscosity is defined as the property of fluid which offers the resistance to the movement of one layer of fluid over the another layer of the fluid. It is measure of an internal fluid friction which causes the resistance to fluid. This is due to cohesion and molecular momentum transaction transfer between the fluid layer. These effects appear as a stresses moving the layers of the fluid. That is next. The when two layers of the fluid, a distance is dy apart from over the one layer to another layer. The difference velocity says u and u plus du as shown in figure. That is in the boundary, the velocity vary from this diagram. The velocity varies near the boundary, solid boundary, that is 0. The gradually the velocity is increases. Then the flow also increases. The velocity together with the relative velocity causes the shear stress acting between the fluid layer. The top layer causes a shear stress on the adjacent lower layer, which the lower layer causes the shear stress on the adjacent top layer. This shear stress is directly proportional to the rate of change of velocity with respect to y. It is denoted as a tau. The tau is equal to mu into du by dy, where mu is equal to constant proportionality of the viscosity or coefficient of dynamic viscosity. The du by dy represent the rate of shear strain or rate of shear deformation or velocity gradient. So mu is equal to tau divided by du by dy, that is velocity gradient. The viscosity also defined as the shear stress is to produce the unit rate of shear strain. The unit of viscosity in SI unit, viscosity is equal to Newton seconds per meter square, that is equal to Pascal seconds. In MKS unit, kg of seconds meter square. CGS unit, pies. 1 Newton seconds per meter square is equal to 10 pies. The kinematic viscosity is defined as the ratio between the dynamic viscosity to density of the fluid. It is denoted as nu. Okay, its unit is meter square per second. Mathematically, it is written as mu is equal to the ratio between viscosity to and density. Sometimes this is also known as Stokes. Next, we discuss about the Newton's law of viscosity. It states that shear stress on the fluid element layer is directly proportional to the rate of shear strain. The constant proportionality is also called as coefficient of viscosity. That is tau is equal to mu into du by dy. The variation of viscosity with temperature. The temperature affects the viscosity. The viscosity of the liquid decreases with the increase of temperature, while viscosity of the gas increases with the increasing temperature because of coercive force and molecular momentum transfer. For liquid, the coercive forces predominate as molecular momentum transfer because in the liquid due to closely packed molecules. So, in the increase in temperature, and the coercive forces are gradually the result of decreasing viscosity. But in the case of gas, the coercive force is small, the molecular momentum transfer is predominant. As compared to liquid, here the molecular momentum transfer is predominant as compared to the coercive force. With the increase in temperature, the molecular momentum transfer increases, hence viscosity increases. Next, we will go to discuss about the types of fluid. The first one is ideal fluid, real fluid, Newton fluid and non-Newtonian fluid. The ideal fluid, it is an imaginary fluid. that is the fluid having a no viscosity. The fluid incompressible, it's having a no viscosity. That is called ideal fluid. But the ideal fluid only, imaginary fluid, it's having some viscosity. Next, in the real fluid, it possesses the viscosity is known as real fluid. In practical, all the fluids are real fluid. The non the Newtonian fluid, the real fluid which obeys the Newton law of viscosity, that is CSS, is directly proportional to the rate of flow. That is, that particular fluid is Newton fluid. All the fluids coming under that category, that is non-Newtonian fluid, a real fluid in which the CSS is not directly proportional to the rate of strain. These are non-Newtonian fluid, that is slurries. This is coming under this toothpaste, slurry are coming under this category, non-Newtonian fluid. Next, we will go to discuss about the solve the problem in this category, that is viscosity. Already in the viscosity velocity distribution over the plate is second order equation. That curve should be a parabolic curve where the u is the velocity in meter per second, the distance is the y. From that we have to determine the velocity gradient as well as CSS at the boundary and 1.5 from the distance. Take dynamic viscosity is 0.9 Newton per meter square. In this way, 2y minus y square. So we have differentiate with respect to y. Du by dy is equal to 2 minus 2y. We need to calculate the first velocity gradient at the boundary. At is equal to 0. Du by dy is equal to 2s. Okay. And next at 0.15 from the boundary at y is equal to 2 minus 2 by, that is 1.7 seconds. From that, in this way, now applying the boundary Newton's law of viscosity, we have to find the viscosity, that is 1.8 Newton meter square and 1.53 Newton meter square. We are using to tau is equal to mu into du by dy. The mu value is already given in this problem. We have to find the velocity gradient. Next, we will go to discuss about that problem, that is in the space between the two parallel plates are filled with oil. Each side of the plate is 720 mm. The thickness of the oil is 115 mm. The upper plate moves with some velocity, that is 3 meter per second, at a force of 120 Newton. To maintain the speed, determine the dynamic viscosity of the oil and kinematic viscosity of the oil if the specific gravity of the liquid is 0.95. All the values are given. So next we will tau is equal to mu into du by dy. Here first you should calculate the velocity, that is pi d n by 60. N is equal to value is given. Okay, next mu we need to calculate the mu. So tau is equal to force by area. Force is given 120 Newton. Area is equal to square plate, that means a square. So 0.72 into 0.72. Here unit conversion is needed. So please concentrate on the unit conversion. Okay, in this way we have to find the dynamic viscosity of the oil and kinematic viscosity of the oil. So kinematic viscosity we have find that. Next one, they determine the specific gravity of the fluid having a viscosity of 0.05 pies and kinematic viscosity of 0.035 Stokes. Okay. Next we will go to solve this problem of to calculate the torque utilized to overcome this friction and power utilized to overcome that viscous resistance.